Good evening, Dr. Cooper. This is Jed Davis. I'm going to talk to you about Module 4. Uh, I already opened up the data that you sent us, and you can see down here I've already made myself a working copy so I don't mess up anything that you sent us. First thing I'm going to do is I'm going to get rid of all of this information here. I don't really need this for the test that I'm going to be doing. I do want to know what campus these kids were at, so I'm going to keep that. And I talked to you, I think it was on Friday, and we talked about how we don't need the scale scores because the number of questions and things like that are different. And so I'm going to get rid of that. So I've got the raw score here. And then I'm going to get rid of the academic readiness, meets, doesn't meet, well, all that sort of stuff. And so now I've just got these three things. I've got what campus they're on, I've got their raw score, and I've got the grade that they're enrolled. And so that's going to be the information that I'm going to be working with. Uh, and meeting with you was a really big help because it helped me with the null hypothesis and all of that and how to look at this data. And so what I'm going to do is I've got all the grades right here, 3 through 8. I've got different campuses. I'm going to sort them by campus and by grade. And then what I'm going to do is I'm going to pretend for this exercise that I separated two schools with the same grades, and one school I put every teacher's got 10 plus years of experience, and in the other school, all the teachers are beginning teachers up to 9 years of experience. And the null hypothesis is that there's going to be no statistical difference in those schools in their raw scores, whether they've got 0 to 9 years of experience or 10 plus years experience. So I'm going to go up here to sort and filter. I'm going to do custom sort. My data, move that so you can see it. My data has headers. I'm going to sort by that, and I'm going to add a level, and then I'm going to sort by the grade enrolled. And you can see I've got one campus, it's got just these grades. That I don't need that data, so I'm going to go ahead and delete that. So here's my campuses. There's my first one, 1041 is the last four numbers. And as I scroll further down, 1042, and you can see those both have 6th grade. So you can see the sort. I'm going to go ahead and pause my video, and what I'm going to do is I'm going to delete a lot of the data that I don't need. So I went ahead and I got, because there were a lot of schools, I did 3 of them, and I know for this test we can only compare 2, and I know we had talked about how next week we'll be comparing 3, but I just wanted to be able to do more than one of these tests, and so that's why I did all 3. And I used the replace to just, I wanted to change the name of the school so it's easier for me to see. And these are people I work with. Holly's my school counselor, and Mitch is my assistant principal. So I decided we all had our own school. And just looking at 3rd graders, I had 75 in my school. Holly's got 89, and Mitch has 88. So uh, here's my key right here so that you know which county campus number went with my school. Okay, as I get started for the F test, I'm going to go to data analysis, my F test there. So my first range is I'm going to do Jed School. And then for my second range, I'm going to do Holly's School. And I've got that. For my output range, I'm going to put that right down here. labels on there. Variable. Let's go from my school. Okay. Output range. Put right here. There we go. Make that a little bit bigger. So this was Jed's school. This was Holly's school. And the variance, you can see there was actually a pretty big difference. 59 to 51. There's the number. And there's my p-value, 0.26. So now that I did that for my school and Holly's school, and this is why I did more than a few schools. I want to do it. I want to do the same thing. Now I am going to do it. It's already got mine in there. And then for the second one, I am going to get rid of Holly's school. And I'm going to come down here and do Mitch's school. I want to see if there's any difference. Okay. And the output range, I'm going to put that right there. So this was Jed's school and Mitch's school. And the null hypothesis was that there was no difference. Okay, and you can see here with Jed and Holly's school, my p-value was greater than 0.05, so statistically there was no difference. So the null hypothesis would be correct. Here, my p-value is less than 0.05, so you cannot assume that the null hypothesis is correct. And I'm really glad that worked out that way. I mean, that was just luck. I just wanted to see a few differences. So now the next thing I'm going to do between Jed's school and Holly's school is run a t-test. And so I'm going to go to data analysis. I'm going to find t-test with equal variances. And so for input range 1, I'm going to use my school again, Jed's school. And then for range 2, I'm going to use Holly's school. I'm going to keep that. My output range, I'm going to go do this below here. I'm going to hit, since we said there was no variance, we got to put in 0 here. So I'm going to do that real quick. And output range, right there. Okay. What? Why did I do that? I did that last time. Got to be Jed's school. All right. So we've got all of mine, all of Holly's, 0. Output range, I'll put right here. Make sure I get that right there. Okay, good. All right, so now I've got Jed's school and Holly's school. So now we look at the p-value here with the two-tail difference, and it's 0.075. So that is greater than 0.05. So again, that means that there's really not a significant difference between the means. So we should just assume that they're basically equal, and any differences we see are just happenstance. They just happen by chance. Now I'm about to do the same thing between my school and Mitch's school. I'm going to pause the video while I do that real quick. So I went ahead and did all of it while the video was paused. So I looked at my school and Mitch's school, and I ran a t-test with unequal variances. And I can see where my the degree of freedom, which up here between my school and Holly's was 160, but here it was 131 because it was unequal variances. And when I look at my two-tailed test, my p-value, it is 0.0000 whatever 398, which is significantly less than 0.05. Which means that there is a significant difference between the means. So we cannot assume that they are equal. So if I take what I was originally saying, like one school has teachers that were just beginning teachers through 9 years experience, and one school had only teachers with 10 plus years experience, I would say there was a big difference in their third grade reading scores between my school, which had beginning to 9 years experience, and Mitch's school, who had 10 years plus. So there you go. Have a great day. Oh, I do want to, I do came back to this because I did, when we had talked about using those campuses, and then I hadn't watched your entire video. I had really just watched the YouTube videos you sent, and I'm glad I did my school, Mitch's schools, or campus 1 and 3, because my school in Holly's, which was 1 and 2, is exactly the example you used. That's why those numbers matched up with what you had. But I did enjoy doing it. I was just about to log off, and then I realized that I didn't want you to think that I just copied exactly what you had done on your presentation. So I made another working copy of our data here, and I renamed it the wrong name. It's supposed to be sixth grade. So what I did is I did keep the first two schools, and I renamed it Jed's School, Mitch's School. And I did the same thing as I did for the other test, except I did sixth grade. I wanted you to see that way. I've got different numbers here. So my school had 249 students take the test, and Mitch's school had 232. And then I ran the F test. And so when I look here for my p-value, it's 0.36, which is greater than 0.05. So there's not a significant difference between the variances. So we're going to assume that they were approximately equal. And then I'm going to go ahead and run the t-test. So I'm going to choose the t-test to sample, assuming equal variances. So my first range is not that. There. Second range, Mitch's school. Here. Output range, I'm going to go up here, put it right underneath this one. It's not that. There we go. So there's my difference. So there's Jed and Mitch. And as you can see here, my two-tailed, my p-value is 0.74. So as you can see with that p-value, we're going to assume there is no significant difference. So for the sixth grade, it didn't matter if the teachers were beginning to 9 years experience in my school or if they had 10 plus years experience at Mitch's school. All right, I just wanted to show you that so you didn't think I was copying exactly what you had done earlier. Have a great night.